Hello, I am Shubha Prasad. I will begin today physics for class 12. In the course of class 12, there is an important section of physics that is optics. We will try to understand what is optics. Optics is the study of light and its various aspects. As we know, light has a great importance in our life as it makes us capable to see things. Therefore, understanding optics is equally important for us. Optics could be divided into two sections. One is ray optics and the other is wave optics. In ray optics, the optical phenomena like reflection, refraction, scattering, dispersion, etc., which are macroscopic phenomena, are explained using classical theory of physics, in which we consider that light travels along a straight line. As we make use of geometry for these explanations, therefore, this section is called geometrical optics. Some other phenomena like interference, diffraction, polarization, etc., which are microscopic phenomena, are explained using wave theory only. That is why we call this section wave optics. In ray optics, first we will take up the phenomenon of reflection. When light coming from any source falls on surface of an object, some light is returned into the same medium. That is, it bounces back in the same medium. This phenomenon is known as reflection. Light is reflected maximum by a very shiny surface like mirror. In mirror, regular reflection of light takes place, which means reflected light goes in a particular direction only and it is not scattered in all directions. When light falls normal on any surface at a point, then it reflects back along the same normal direction. But if it falls on the surface at a point making some angle with the normal direction to the surface at that point, which is called angle of incidence, it is reflected in a direction making same angle with the normal in the same plane, which is called angle of reflection. For better understanding of the phenomenon of reflection, we have two laws of reflection. The first law says the angle of reflection is equal to the angle of incidence. And the second law says that the incident ray, reflected ray, and the normal to the point of incidence all lie in the same plane. There are various activities with mirror which you have already studied in previous classes, and they all are in agreement with these laws. You can try to recall them. These laws are true and not only for plane surfaces but also for curved surfaces. Therefore, we can apply them for image formation in spherical mirrors and make use of this knowledge for our daily practical purposes like rear view mirror in vehicles. The spherical mirrors are of two types, concave and convex, about which we have already studied in earlier classes. We have clear idea about the pole, focus, center of curvature and the principal axis of the spherical mirror. We are also familiar with the Cartesian sign convention for measuring distances in image formation in spherical mirrors. We also know that when parallel beam of light is incident on a mirror, the reflected rays converge at its principal focus in case of concave mirror and appear to diverge from the principal focus in case of convex mirror. Let us now talk about the image formation in spherical mirrors. The image of any point is formed when rays emanating, that is originating from that point, actually meet after reflection through the concave mirror and real image is formed. But they appear to diverge from the point when produced backward, then image formed is virtual, as in case of convex mirror. Now what is real image? The image of an object which can be taken on any screen are real image, and these images are inverted. Virtual image cannot be taken on a screen. They are formed behind the mirror and they are erect. For image formation of any point, we can take any two rays emanating from that point and tracing their path to find the point of intersection, which is the location of the image formed on reflection at spherical mirror. These rays from the point could be number one, the ray parallel to the principal axis, which after reflection goes through the focus of the mirror. Number two, the ray passing through or appearing to pass through the center of curvature of the mirror and retracing the path after reflection. Number three, the ray passing through or appearing to pass through the focus, which after reflection goes parallel to the principal axis. Number four, the ray incident at any angle at the pole is reflected back, making same angle at the pole in the same plane following law of reflection. In earlier classes, we have already observed the image formation of an object by spherical mirror, and we know that when object is at infinity, its image is formed at the focus of the spherical mirror. Real image is formed in front of the concave mirror and virtual image is formed on backside of the convex mirror. As the object keeps on moving towards the concave mirror, the size of the image and image distance both keep on increasing, and when object is between focus and pole of the concave mirror, an enlarged virtual image is formed behind the mirror. You might recall its practical use. In case of convex mirror, a virtual and diminished image is formed behind the mirror, which also has a practical use. You try to recall it. By tracing the ray diagram using any two rays emanating from the given object, we can derive an important relation between the object distance u, image distance v, and focal length f of the mirror, which is known as mirror equation or mirror formula. This well-known formula is 1 by f is equal to 1 by v plus 1 by u. We can also find the size of the image relative to the size of the object, and this ratio of length of image h dash and length of object h is called magnification m. Mathematically, m is equal to h dash by h, which is also equal to the ratio of image distance v to the object distance u. Depending on the location and type of image, the magnification could be positive or negative. This magnification is an important characteristic of an optical instrument, which we will discuss later. Students, I hope my efforts to explain the phenomenon of reflection was useful for you. Next time, I will discuss some other phenomenon of light. So, see you in the next class.